Yeah, g'day everybody. Thanks for joining us this evening. Just give me a minute while I bring Stefan in. G'day. I'm Mark.
Hi, I'm Stefan.
And welcome to our live stream. Now, we're coming up on Christmas, and this is a time for someone like me to get a holiday. Stefan, being self-employed, do you get a holiday, or do all of your customers go into maintenance and start needing parts?
Well, yeah. I will try to take a few days off, but when I take a day off, I might still end up in the shop. I guess that's the hobby side then.
That was kind of my next question, whether you've still got motivation to go and do it as a hobby.
Yeah, absolutely. It's still what I like to do. And I will just either come out here and clean machines and have a coffee, or I will work on something.
Do you have anything specifically planned for this season, this holiday season?
Well, I have two articulating indicator stand arms, like the Noga arms, but from a different manufacturer, and I want to make a fine adjust base for them. That's kind of
nice.
on the to-do list for like 3 years. And somebody needs to do that at some point.
Yep. You know, I really want to try and finish my tool holders for the lathe, my grinding hubs for the surface grinder, and all of these projects here, which, I mean, I was looking at it thinking, if every one of these items is like a 1-week video, this is work through to like October.
Did your schedule is set? Have you ordered everything that you need for those days?
I think so, yeah. I think I've got everything I need.
Because getting parts during Christmas and New Year is always a little bit troublesome.
Yeah, but of course you're doing the commercial side of stuff. You know, you order stock, the right stuff, the tools. I'm a hobbyist. I'll just kludge up something.
Yeah,
cool.
but for seals I read seals and paint jobs, so you need paint and seals.
Oh yeah, definitely not doing paint job at this time of year. It doesn't dry. No. And yeah, it would be cool to do the nick and seals, but I just more other things that are more important.
Just fill up the oil.
Yeah.
Just top it off.
Yeah. So talking about materials, do you have a favorite?
When I can choose a material, like no technical requirements, just I like it. Yes, what's it called? German silver. It's in German it's called Neusilber. It's a type of brass alloy. It machines like a free machining brass, but it's a little bit nicer.
Is it a silvery color or is it more brass color?
It has a yellow tint, but it goes towards brass colored. There's a stick of it. It looks like this. It's almost like brass.
Okay. Yep.
And it machines beautiful. I really like to work with it, and I have a customer that requires me to do a lot of parts out of it.
What are its special characteristics? Magnetic, non-magnetic,
nope,
weldable?
Non-magnetic. It chips break super short, like with brass.
Yep.
Surface finishes you get with it are marvelous. Tool holds up forever.
Yeah.
And yeah, how do I describe this? You get precise parts very easy with it.
Okay. It's funny. coming from aviation, I should love, high strength aluminium, 70705 and stuff. But I actually really like cast iron. It makes a mess.
That's a good answer.
Yeah.
If I have to make like machine accessories, gray cast iron or ductile cast iron is great.
Yeah.
The continuous cast.
Like I have a real problem bolting aluminium onto a machine. Like even mounting like linear encoders where they themselves are aluminium, the first thing I look at is like, can I make this out of like cast iron? Total overkill, but yeah.
The aluminium feels wrong.
Yep, does. So if that's your favorite, have you ever worked with like those nickel, chrome, cobalt, super alloys?
Oh, these super alloys. No, not really.
Okay. So Marem, Renault, or Rene, Inconel-X, that sort of stuff?
No. I fortunately do not have any customers requiring that. The closest might have been a shim material with a high nickel content that I worked with. I got it as sheet metal, and the customer required me to make parts out of it. It was very gummy. Very.
Yep.
It tended to tear and not cut very nicely.
Yep. Yeah, that's what you hear about the super alloys. They're supposedly pretty beastly, aren't they? Yeah.
Yeah. Have you worked with those? Because
no.
aviation?
Yeah.
Drilling out bolts?
Well, the closest, I remember back when I was at Laudereer, we sent our first, I think it was our first C-check out to a shop in Asia. So the airline flew the 777 out to this maintenance organization for what is a pretty small maintenance event. When you're doing the first C-check, it's really only 2 weeks work or so. There were problems with the fuel nozzles. They were an early, it was quite a young engine, the GE90 back then. So they had to replace a set of fuel nozzles, and they started unscrewing them and started snapping off bolts. Which, of course, they're all thread bound and horrible. And they needed a special tool as a drill guide to be able to drill out the damaged screws before they installed them. And so this is a big MRO doing wide body aircraft. They got sent this drawing of the special tool, and after a week they still hadn't made it, and we had to pay General Electric on-wing support to fly out first class from the UK. And I tell you, this block of steel, even I could make it. All it was a 1 inch thick block of steel with 4 halfway precise holes in it. And this big MRO was not capable of punching 4 holes into a piece of steel. Yeah, it's pretty sad. Yeah. I should probably dumpster dive, because I've sometimes been to engine shops, and of course they scrap parts. So, well, I guess they do have some MAR-M here, which, I guess I could try poking a hole through it and seeing how horrible it is to drill.
I imagine drilling would be a nightmare.
Yeah, just awful. I mean, most of these parts are, of course, investment castings. Most of these features just get cast into them, except maybe the film cooling holes, which are probably laser drilled these days, or EDM'd or something.
EDM. I think the interface is ground on most of them. The what's it called? The tree.
The dovetail.
Or dovetail, yeah.
It's hard to say. I mean, it doesn't. Well, this is a used pass, of course, so there's a lot of fretting from its use, but it could well be ground, yeah. But yeah, supposedly some of the worst materials you can possibly have to work with, huh?
I'm quite happy that I do not have to deal with things like that.
Yep. Yet.
Probably.
It's just a question of the next customer.
Yeah. Doc Metasonur, sorry, asks, what about M152 or 17.4? I do not know the M152 steel, but the 17.4, I hear our colleagues in the US use it a lot. It seems to be a pre-hardened stainless, or a stainless that can be hardened, but it's relatively uncommon here, so I have never really used it.
Do you tend to use a lot of those pre-hardened, quarter-hardened, half-hardened steels?
Yes, 42 chromoly in the QT delivery state, which
Yep.
is quenched and tempered. I use that a lot when the customer doesn't need like hard, but a little bit of toughness. Comes in at 33, 35 Rockwell C. Sometimes Tulox 44, which gives like in the 44 Rockwell C range.
Oh wow, yeah, that's starting to get pretty tough, huh?
Yes, it's on the edge of what you can drill and tap with high-speed steel. Sometimes it works, sometimes you have no chance with the tolerance of the material.
When do you start moving to polycrystalline diamond, monocrystalline diamond tools, or CBN tools?
Diamond only for non-ferrous materials.
Oh yeah, yep. Sorry, yeah.
Aluminium, brass, plastics, and copper, of course. And CBN.
What advantage would a diamond have on plastic?
The cutting edge. If it's a reinforced plastic,
Oh, okay.
it will last longer. And diamond will give in clear plastics like plexiglass a optical clear finish.
Oh yeah, yep. Nice.
I do some parts that I fly cut with a diamond, tiny little parts, and I fly cut them with a diamond without any polishing steps.
Yep. Yeah, I saw that video. Yeah. Those are little tubes with the 45 degrees ends on them.
Oh
right?
yeah.
Yep. Yep. And what about CBN? When do you move from carbide to CBN?
It depends. So with a commercial, when you buy a CBN insert, those tend to have a cutting edge prep that makes them a little bit negative. So negative top rake.
Yep.
And they want a certain cutting pressure and also a certain hardness of the material to work. So under 55 Rockwell C, a commercial CBN insert that's not been altered by the user
Yep.
will not work really. It will leave a really bad finish. But you can take a superfine diamond wheel and you can put a super sharp, slightly positive edge on them, and then they work in almost everything.
Right. So this is kind of the secret weapon for basically high-speed steel and everything, right?
Yeah.
Yep. Could you even turn carbide with it?
Yes, I have shown that on YouTube years and years ago, but it's not ideal. For cutting carbide, you want diamond.
Right. Yep. Yep.
Hey, we have a few questions.
Yep.
When will we see an EDM machine in your shop? Hey, that's one for you.
No, won't ever happen in my shop, I don't think. What about yours? Since you've now taught me how to do removing broken taps with just normal carbide, I don't need one anymore, right?
Yeah, true. I would go for no. Neither wire ED. I would like to have it, but outsourcing EDM work is cheap enough to not
Yeah.
have
It's a
being
very
bothered by.
high maintenance machine, isn't it?
Yeah, a wire EDM at least it is.
Yeah.
You have the filters, you have the water to deal with,
Yeah.
and well, the wire.
Yeah. Yeah. I mean, sometimes any one machine might sit for a month without being used, and
Yeah,
I don't see that working with something like a wire EDM.
they don't like that.
Yeah.
They don't like that. Hey, do you still use high-speed steel as cutting tools?
Very rarely now. Yeah. Basically, not because I don't like the way it cuts, but with the CNC, I like
Oh,
the programmability of being able to switch out inserts,
repeatability.
repeatability. Yeah. 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 You still use quite a lot, don't you?
Less and less. A lot of inserts. I grind a lot from solid carbide, like old end mills, but it's probably 75% inserts by now.
Yeah. Do you have a tool table set up for your lathe tool holders in your DRO?
Yes, but it's it's changing. I'm changing stick out on tools all the time, but it's super quick to reset the tools.
Yeah.
I just take a little bit of cut, measure the diameter, and enter it.
Yeah.
It's like not a big deal if I change something.
Yeah, I kind of lack the discipline to keep a really rigid tool table. Like I find I never really have confidence in my tool table. Like, did I touch off this one last time, or did I alter something, and then I end up, retouching off all my tools before a job just to be sure. Yeah.
Oh, I have that on the CNC mill. I have like 10 tools that I never touch.
Right. Yeah.
They are also modeled in Fusion with
Yep.
the correct stick out, and I never change those. I do not change the stick out or like the neck length or something like that, or use a different holder.
Right.
Because some are super slim shrink fit holder and some have a big collet nut that will cause
yeah.
problems.
Yeah. So if you wear one out and have to switch out a shrink fit, you
Blowtorch.
then just have to dial it back in. You don't have like a tool setter, right?
No, I use a steel scale. I put it approximate like half millimeter tolerance in the same place. Then I measure it with the height gauge.
Okay.
Because the HSK holders are super easy because the length is measured off the face on the back here.
Yep.
So you just rest them on a piece of precise pipe and measure the length with the height gauge. Super easy and very precise.
Yep. So if you've got a favorite German brass or new silver, do you also have like a material you just hate, and even refuse to make anything in?
There are certain classes of I hate that material. There's things like beryllium copper. That's just toxic.
Of course, yeah.
The dust is very problematic.
Yeah.
I will be very hesitant to make parts of beryllium copper. And there are materials that are just bloody annoying, like G10.
Don't know G10.
That's a epoxy with glass fiber. Think an FR4 PCB.
Yep.
Same material.
Yep.
Just thicker usually.
Highly abrasive.
Super abrasive. You get the itch.
Yeah.
And yeah, it's very unpleasant material.
Yep. What does it tend to be used for?
My old day job used it a lot for electrical installations and for heat shielding on molds.
Oh, right. Yep. Yep.
Little side note, it grinds. It grinds really well with a silicon carbide wheel. You can really nicely surface grind it.
Okay.
Because I read the question here, do they cut it with water jet? Yes, it's often cut with water jet, but also often milled. I had to cut it on the table saw a lot. We had a dedicated diamond tipped polycarbon diamond tipped circular saw blade for a large table saw to cut it, and
Yeah.
yeah, it was very. It's not fun to work with,
No, you'd want good dust extraction, huh?
and a mask.
So, what kind of precision can I expect from a heavy industrial tool grinding machine? Can I grind flat stock with it? I mean, I would say a lot of this is driven by knowledge. You know, the more knowledge you've got on the right grinding wheels and stuff, but I don't think any tool grinder is an ideal surface grinder, is it?
I tend to agree. Yes, there are just a lot of adjustments on a tool and cutter grinder, and they're usually built a little bit lighter. I have not seen a Schütte in person, but I have the book from them, and they appear to be fairly heavy-duty tool grinders. And I think you can, depending on the size of the part, hold like 5 microns and a little bit better, maybe. I don't. I'm talking off my rear.
Speaking of grinding, we got a question from Luke from Malta. Stefan, Luke and I have got our Jones and Shipman surface grinders. He's also got a MyFred cylindrical grinder. Do you have any suggestion of a general purpose grinding wheel? Like if you're just grinding non-hardened steel, where do you start? Do you have a go-to?
Yep, that's I preferred this earlier. A aluminum oxide wheel, hardness J or I.
So and F is soft, right?
F. It comes earlier in the alphabet. Yes.
Yeah.
It should be softer then. That will work very well too. And the grit between 46 and 60 for a general purpose wheel.
Okay. Yeah.
So fairly rough.
Yep. Oh, that's good because Luke found there's some weird Dutch sort of surplus tooling sort of company with the world's worst website. But he found you could get 10 of these for $55. So we each bought 10 of them. And I mean, they never, at least for me, they never clog up. They're so soft that it's constantly wearing down. But just kind of curious on that.
Yeah, grinding is fairly inexpensive to a certain degree.
Where do you go from there? So for hardened, what's your go-to for a typical hardened Rockwell 55 or something steel part?
Same one. I also got the question why there are holes in the wheel. There are several holes.
Oh yeah, yep.
That's for balancing.
Yep.
I just take a cordless drill with a masonry bit.
Okay. That's the brutal method, huh?
Yeah. That's up for 55, 60 Rockwell C. Perfectly fine. But when you get into steels like high-speed steels, they will wear the wheel down fairly quick. Then ceramic grinding wheel like the Norton 3SG and 5SG wheels work better. These are, I think it's a ceramic grain, better dirt. So these are dirt and these are better dirt glued together.
Yep.
And these hold their their sharpness better in certain steels.
Okay.
But they are very expensive. Two of these cost like $100.
Okay. Because I've got this wheel, which is nearly worn out, which came with my grinder. I've no idea what it is, but it does
could be
get very
everything.
nice surface finish.
The color of the wheel does not tell you much.
No.
They can dye them whatever they want.
Yep.
So with those two, you can deal with everything steel related.
Yep.
By the way, it doesn't matter the manufacturer, if it's Tyroleat or Norton or whatever.
Yep.
Usually they all work.
Yep. Do you tend to grind much like aluminium or brass, copper, those sort of things?
Yes. That's silicon carbide wheel.
Okay.
That's what back in the day was used for. People try to use it for carbide, but it really sucks for carbide.
Yep.
You end up in a sandstorm, basically, because the wheel wears down so fast. But the grain on the silicon carbide wheels is way sharper once you dress the wheel. It's really a very free-cutting wheel. And it works excellent on aluminum and copper, soft materials, and rubber. A lot of people do not know that you can grind rubber amazingly well.
Yeah. Do you need to freeze it first?
No.
Like harden it?
People that tell you to freeze rubber for machining, that doesn't work.
Okay.
I tried it several times with freezing with dry ice. It doesn't work. No, you can go right with the wheel against the rubber and grind shapes and all sorts of things.
Okay. What is this something you do quite often?
Sometimes. I have some parts that are steel parts with an inset rubber piece.
Yeah.
And I glue the rubber in, and then I grind the rubber to shape.
Okay. Do you also grind any plastic parts?
If I had to do, this would do it.
Yep.
Phenolics grind very well, like the phenolic resin that's fiber reinforced or paper reinforced, and also the epoxy materials grind quite well. And from there, you go diamond.
Right. Yep.
For carbide.
Yep.
I don't have a diamond wheel that's on the grinder itself. A D. There are different grit scales for the diamond wheels around the world. In Europe, we use this D scale. From small number is a super fine wheel, like a D40 is a quite fine wheel, and a D126 is a general purpose wheel.
Yep.
So that's something to, if you plan on doing any carbide, a D125 or D126 is perfectly fine.
Yep. Yeah, I think that's what I've got on the Clarkson. Although I've got a couple of diamond wheels, but one of them doesn't have the marking anymore, and I always get confused as which one's the coarse one, which one's the fine one. Soon find out when I start grinding.
Oh yeah, that's learning to grind is really fun.
Mm-hmm. Do you use CBN grinding wheels much for high-speed steel? Or?
On the D-bit grinder, yes.
Oh, okay. Yep.
I have a handful of smaller CBN wheels for the D-bit grinder. I do not really. My surface grinder doesn't have the spindle power to fully utilize a CBN wheel, and they are really expensive and annoying to dress if they get out of shape.
Yeah, that was my next question. How do you dress them?
It's annoying. So I learned something about dressing diamond wheels recently. So there are two main methods. One is grinding a material that will tear out the diamond or the CBN grain from the wheel's structure, like grinding a soft steel works okay-ish, and grinding molybdenum works better.
Okay.
With the drawback, molybdenum being very expensive.
Yep.
Robin has quite a good video on that.
Okay.
Mr. Rancetti.
Yeah.
So
isn't molybdenum's also quite toxic, isn't it?
It's a heavy metal. I think
Yeah,
you're not supposed to breathe it in.
yeah, yeah. Makes sense.
And the other way is to grind the diamond wheel. So you put it's a super dirty process. You
Yeah.
put imagine this a diamond wheel on a rotary axis like a punch grinder.
Yep.
Let it spin. Then you come in with a silicon carbide wheel and you cylindrical grind it.
Oh, right. Yeah, yeah,
That works amazingly well.
yeah.
It eats up the silicon carbide wheel quite quickly.
I was going to say, best man wins, huh?
Yeah, but it really works. It eats away the diamond,
Yeah.
and then you can go back.
Yep.
So
Do you tend to dress your diamond wheels like on your tool grinder and stuff, or do you just accept them as they are?
I try to not mess them up. So when I get a new, like a cup wheel that has a face and it doesn't run out horrendous, I will just use it. And from where it will dress itself during use,
Yep.
most of the time. And I try to grind in a way that maintains the sharp edge on the front.
Yep.
So trying to grind from the inside out.
Yep.
Tool grinding can be a little bit of a pickle sometimes. You're tempted to take fairly heavy cuts with a grinding wheel, and super abrasive wheels are not the biggest fan of that.
Yeah. Yeah.
It smells like burnt diamond wheel sometimes.
Yeah.
It's a very, very specific smell.
This is one thing I'm looking forward to getting my new lead screw mounted on my Clarkson. So I'll finally actually have a scale, because so far it's sort of just been by feel, you know. I really wonder how Clarkson managed to make their production, like cutting tools and stuff, on machines that have no scales.
I have no clue.
Yeah.
I've seen the old advertisements of Clarkson, and I don't know. Very skilled labor, probably.
Yeah, I guess, yeah. And maybe they just had, and it seemed they had every machine set for a single task. But yeah, how did they measure for wear and stuff? You were showing before, because I want to talk about balancing weights. Let me just switch to the head down camera. Like, I've got 3 hubs so far. This one has no form of balancing. I've got balancing weights on the nut and nothing at the back. And then this one's nothing on the nut, balancing on the back, which Luke and I were thinking is probably the best, because this should be the most protected against dust and stuff. But my question was going to be, what's the best methodology for making these kind of balance weights? And don't tell me go and get a masonry bit and attach the side of your...
Well, the masonry bit is always an option.
Yeah, so do you start by like turning a ring, putting the 2 tapers on it, and then drill it all, chop it all, and split it? What would be the method?
Yeah, I would make a ring. I would probably then cut it up. Maybe either with a fixture on the surface grinder with a cutoff wheel.
Yep.
Or with a slitting saw on the milling machine.
Mm-hmm.
Drill and tap, and then use a thin slitting blade, a slitting saw, to slit them.
Yep.
To cut them apart.
Because I see this one's only slit with a straight line. Some of them have a curved line, which I'm assuming they're making
that's interesting.
Yeah, I'm assuming here they're making 2 rings and just wasting half of them. Yeah.
I mean, you could make 2 rings, solder them together, or glue them together.
Oh, yeah, yeah.
drill on the split line.
Yep. That's a good idea. Because the other idea I was thinking of was,
Or send them out for wire EDM.
yeah, of course. Because the other idea I had is, in my video today, I cut off those expanding mandrel petals. So I've got a whole bunch of sort of weird, partially curved stock at the moment. And I was kind of thinking of just setting up the maho as a horizontal, and just, milling them one at a time, and then slitting it off, move it forward, do another one,
yeah.
slit it that way.
Yeah, if you go CNC, that's absolutely a good solution. Just cut the contour. I mean, you could even slit it with a small end mill in the same setup.
Yeah, right, yeah. Yep.
Would be awfully slow on the Maho.
Yeah.
And then saw it off with saw blade.
I guess the other option is just make inners and outers, and as you say, either clamp them, glue them, brace them, drill them. Make up a little drilling jig.
I think they would hold up in a vise quite well, because you have. It's like, I'm pointing at your monitor, right?
Yeah.
Because you see that. Because there are like 3 points of contact if you grab them in a vise.
Oh, that's true. Yeah. Yep.
I think that would be doable without too much fixturing effort.
Yep. So basically, maybe I'll try that. Just making inners, outers on the horizontal, and then watch the space. So what do we have in the comments here? Mark, a question for you. Since machining is a hobby, how does your family, do they support you? Well, my kids are grown up and left home, so it's just me and my wife here. She works a lot. She's self-employed, so so from that perspective, often that there's no big conflict with that. I do try to, if there's time for the both of us, then I don't go in the shed. We'll go and we go out to the movies. We'll go out and do something.
Yeah, that's reasonable.
Yeah. Her work has quite a seasonality to it. There's a silly season for her work where she works like crazy, so it makes no difference what I'm doing.
Did your kids ever show interest in machining?
Not really.
Or engineering topics?
I mean, they're both studied physics.
Oh.
Yeah, so
that's both not too far away.
Yeah, both quite technical. And I think as they get further through their degrees, the laboratory work is more interesting for them. They start getting contact with the university's engineering department as they need samples put on substrates, this sort of thing. So, there's some level of interest there, but it's,
one day they will come.
Yeah, this is a pretty, let's say it's a pretty special hobby we have here, isn't it? In this little community, there's right now, 600, I think there's about 600 people watching right now.
Oh boy.
But that's 600 out of 8 billion on the whole of the world. Huh?
Well, I couldn't fit 600 people in here.
That's true. Yeah.
And I have to be careful to not pick my nose. That would be embarrassing.
Yeah, that is quite funny. With I don't know what it was like before the internet, but I know now probably 5 or 6 guys roughly in the area around Vienna, which has got 2.5 million people. And, we're on the same forum together. We'll sometimes, I go to buy something off the classifieds, and it's like, oh, hi, Yerk, and things like that, you know. So I think it's quite a unique hobby we have here, or at least a very small interest, isn't it?
Yeah, true. We had a small machinist meetup near me a few weeks ago. That was like 16 people.
Oh, that's good. Yep.
So we tried to do meetups like every few months, and we're usually good 10 to 20 people.
Oh, that's good. Yeah, I was invited to a meetup over in Romania, but it was either this weekend or last weekend, and I was just like, it's a busy time of the year and stuff. I was in France for 2 days this week on work, and yeah, it just didn't work out, unfortunately. Would have been nice to go over there. Let's move on to engraving. Okay. Now, in today's video, I already showed that Luke did this beautiful dial. Now, he feels that this writing, let me maybe move it up a little. He feels the thickness of this writing may be a bit too thick. He did it with, I think, high-speed steel D-bit. He did try carbide, but found he was having issues with chipping. And I guess the question is, in the choice of D-bits, pyramid style, drag engraving, tiny end mills, what can you do to get that beautiful, really, really fine engraving?
So that's a two-part answer. It depends, as usual. No, for lettering, for anything that's like numbers or characters, a small ball end mill, a 2-flute carbide ball end mill.
Okay.
It will give you the most beautiful, the nicest finish engraving of everything.
Yep.
And for the lines, I wouldn't engrave them with a rotary tool. I would shape them with a stationary tool.
Which I think is what Luke did. Yeah, on this one. Yeah.
They looked in the picture very, very crisp, so I suspect they are shaped.
Luke's on there, so jump on there in the comments. Tell us how you did it there, Luke.
Yeah, the lines look really crisp.
Yep.
So yeah, ball end mill works really well. You have to be a little bit careful with the depth of cut, of course.
Yeah.
Because that's a direct effect on the line, on the weight of the line.
Yep, the width. Yeah. What when you say a small ball end, what's small in your world?
Like a 0.5 or 0.8 millimeter.
Okay. Yep.
It will cost a little bit of money, something like $20 or something like that, and they last forever if you don't break them.
Okay.
Take light cuts.
Yep.
Like I take 50 micron increments until I have the depth that I like. Cutting oil, and it just works well. You can run them at extremely slow spindle speeds, like with a 3000 RPM spindle, it's not a problem at all. You just have to go a little bit slower with the feed rate. But you don't need an air spindle, because I read that you can go faster with the feeds if you have a high-speed spindle. But for the process itself, it's not necessary.
So now that I've got a air spindle, I don't need one, right?
The other one, like all the commercial, I will probably rough some, what's it called? Rough some feathers. All the commercial engraving tools, like the multi-flute, tapered combination tools that are tapered and have a ball end, they all fall short of the simple ball end mill.
Oh, okay.
The ball end mill is the simplest and best solution. And it doesn't matter what you want to engrave. if it's steel, hardened steel, aluminium, or Baltic birch plywood. It will engrave everything.
And do you tend to do your engraving with the electric spindle on your CNC or?
Yeah.
Yeah.
Most of my engraving these days is like lettering,
Yep.
like serial numbering, and I just have the CNC do that. These days, also quite a bit of laser engraving,
Right. Yeah. Yeah.
but for certain reasons, I have to still engrave a lot. It's easier to clean
Okay. Yep.
on a clean room level. You can easier wipe through a shallow engraving than the rough surface of laser engraving.
Right. Yep. Okay. So, and yeah, what sort of spindle speed do you have on your CNC?
24,000 RPM, if I
Okay.
remember correctly.
And what's your engraving surface speed that you set?
The feet, I
Feet,
think,
yeah.
I think I have set it to 20,000 RPM, and I go like 200 millimeters per minute. Relatively
Okay.
slow.
Yep.
I'm usually not pressed for time on the parts I make.
Right. Yeah. Yeah.
It's more important that I do not get overswings of the machine on the end of when there is a sharp edge in
Yep.
a letter, like in an L,
Yep.
so the machine doesn't overshoot.
Sure. Yeah. Yeah. And I guess the thing too is like engraving's almost always one of the last processes, and you don't want to scrap parts, right?
Yeah, you want that to work out really well.
Yeah.
Erasing and engraving is really annoying.
Do you ever use drag engraving at all?
I have in the past, but not for any real application. I played around with it because I was curious.
Yeah.
I made some spring-loaded carbide drag engravers,
Yeah.
but haven't really used it for anything.
Yeah. Yeah. I used it, but also was not super enthusiastic about it.
I mean, you get always this little pushed up material at the end of each line.
Yeah. 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 You get burrs. Yeah. Have you ever tried using one of those pyramid grinds?
Yes.
And also just a burr creator, aren't they?
No, those work in hardened materials quite well.
Oh, okay. Yeah.
When you want to hard engrave and you need really fine lines, that works quite well.
Okay.
And they work excellent as a spotting drill.
Yep. Yep. That's actually a good point because I'm planning to engrave tool numbers on each of my tool holders as I make them, but I've already got 5 or 6 from Schaublin which are hardened. So maybe I'll hard engrave those.
I did this to mine. I just hand engraved them with a die grinder.
Yeah.
Laid out a horizontal line.
Yep.
And then freehanded it.
No, that's too practical. Actually, speaking of engraving, my next little issue I've got for you is this one. Let me just focus again. So,
we're showing off grinding spindles. I have one too.
oh yeah. Let's jump back to that first. So this is an air grinding spindle. What sort of speed?
That's a good question. Approximately 60,000 RPM, I guess.
Yep.
But the neat thing about it is it has an 18 millimeter shank that fits a boring head. And the air coupler is free to spin.
Oh, right. Yeah.
So it can orbit. You can have it. You can have it in a boring head.
Yep.
Oh, camera, what are you doing? You can have it in a boring head. Go do this motion, orbital motion.
Yep.
and it will not wind up the the air hose.
Yep.
And yeah, you can grind bores with it on the milling machine, like a chick grinder for very poor people. Well, these are not cheap.
Yeah, yeah.
It's,
Have you ever considered building a mount for that to mount it sideways on your surface grinder?
Yes,
Yeah.
absolutely.
Yeah.
It's on the list. It's like number 755. I
Right.
think.
Yeah.
I've used it on the lathe for ID grinding quite a bit.
Yep.
Goes in a boring bar holder
Yep.
and takes, call it 3 and 4 millimeter, and works quite nicely.
Yeah. So back to my little issue here. So that beautiful French grinder, which my wife bought me from Luke, has got both the bigger tool holder, which I think not just gyrates, but also reciprocates. Yeah, it's a pretty special sort of thing. So that's another story. But for doing engraving, I've got this basic one. Now this is hardened, and it's got the wrong pull stud, which is not removable. So do I throw it in my heat treatment oven, anneal it, and then machine it off, drill it, put in the pull stud geometry, and then harden it again?
That I wouldn't do that. I doubt that it will run true after that.
Well, I mean, it doesn't actually have to run.
Oh, right, it's stationary, but if it's
Yeah.
tilted, if it's
Well,
like
for
bent.
engraving, if you
Oh, yeah, okay, for engraving it's true.
Yeah, it wouldn't be any good for grinding. But I don't think you use this one for grinding anyway, because you use the other one.
Yeah, but the rough adjustment and your spindle is not
Yeah,
perpendicular anymore.
yeah. So okay, if I'm not allowed to anneal it, what's plan B?
I would take an angle grinder to it,
Yep,
cut
What-
off the end,
yep.
and it's probably not screw hardened anyways.
Oh, okay, yeah,
It's
yep,
probably case hardened.
yep,
I would put it on the milling machine standing vertically up.
yep, yep,
Helical mill a hole into it
yep.
and thread mill for a different pull
Right.
stud.
Yep. Okay.
That's
Oh,
what
that
I would
makes
do.
sense.
You could
Yeah, I guess I was
probably
thinking-
tap it.
Yeah, you're probably right. By the time you've put the pull stud clearance, the thread starts reasonably deep, and you may well be into an area that's still quite soft. Huh?
Yeah, there is a hole in the back. How deep is that?
About here.
It could be that the inside of the hole is hardened too,
Ah, yeah, of course. Yeah, yeah.
because
Okay.
it's an exposed surface.
Right. Yeah, that makes sense.
But a carbide end mill will deal with it.
Yeah. So basically, just helically millicle out the clearance, and then make up a thread mill. Yep.
Yeah.
Okay.
Be sure that the gauge length is correct. The back end of the taper matches
Yeah. Because
a
this
tool holder.
whether it's BT or no, it's not.
Yeah.
Yeah. That's a good
But
point.
yeah, I would cut it off with an angle grinder and go from there.
Yep. Okay. Because if that works, I then have to do the same on the beautiful reciprocating,
Oh,
because it's also got the same pull stud. I'll have to see, maybe it's got a removable shank, but
Oh, yeah.
I'll have, yeah.
I have a measuring microscope, a spindle microscope, also with a 40 taper
Yeah.
that I have to do the same. It has an interchangeable shank, but the manufacturer either has tightened it with all the torque or glued it in.
Oh man.
So I'm a little bit worried that I might break the microscope in process of undoing the shank. So I'm just cutting it off.
Yep.
And also people love when I take an angle grinder to precision tooling. I get a devilish joy out of that.
Yep. I guess because that's the other option. I mean, I could just lop this off here and use electric glue to glue it onto here.
In all honesty, you could even make the plate, the dovetail plate, looks very approachable to DIY.
True, yeah. It's not brain surgery, is it?
As in two parts, you can even grind it.
Yep. Yeah, they made it out of one, but you're right. There's no reason it needs to be. Yeah.
Yeah, but now you can you have the punch grinder too, so you can do round parts.
Oh, that's true. I was looking at this thinking, this won't fit in the punch grinder. Need a bigger punch grinder. Right, we should do a bit of a look back. There's probably some questions we've lost here.
Yes. Mark, are you an expert on feature cam? Christoph asked that.
I mean, I've got a seat of feature cam from 2005, and I have no idea what it looks like today. That's 20 years ago, you know. Yeah, I would definitely not call myself an expert on it. I mean, but it's. I mean, I find all cam software difficult to use. I've had a play with CATIA's cam modules. I've tried FreeCAD. I'm trying to work with the beta of Onshape and FeatureCam, and of them, FeatureCam is the one that works best for me. But yeah, definitely not an expert.
Oh, no with CATIA and FreeCAD, you have chosen two very easy ones.
Yeah, really. Yep.
There's a quick question. Have you considered getting the big 2037 universal rotary table for the decal, or is it too big? It's too big. That's a large tilting rotary table that mounts instead of the table, and it weighs a lot. And that's too much weight for my taste to hang off the mill constantly. It belongs on the bigger machines that I made.
Do you quite often run into the size limitations of the FP1?
No.
Okay.
I don't. I mean, you can still do very large parts or hold very large parts if you have only to do a small machined area on it.
Yep.
It's rare that I have to machine like a large plate completely flat.
Yep.
It's more like I get a long turned part that needs a few slots milled or something like that.
Yep. I guess if you do get a job that needs a large surface area, you know people, you can use a machine.
I have. Yeah. I have in the same village. I have a lathe shop that I work with. He has fairly large turning capabilities, and I also know people with larger mills.
Yeah.
So I'm not really depending on a large manual mill for myself.
Yep. Question for Stefan. Oh, that was the one, the big university table.
Oh, yeah.
Yeah. What kind of aluminium is the best for machining in Europe?
Ooh, in Europe?
Generally, the harder the better, isn't it? Like 7075 machines beautifully, huh?
I don't like it that much. It behaves. It's so crunchy when you get. For a lack of a better term, it's so crunchy when you cut it. I like 6082.
Okay.
It gives a nice finish. The chip never breaks. And always up with this rat's nest. Oh yeah, and Nikolai says it. Best aluminum is 5083 cast.
Oh yeah,
That's
yep.
the precision
Yep.
aluminum plates that are cast. That's my favorite.
Yep.
That's a good answer.
Yeah, true. Yeah.
Yeah, but I try to buy the aluminum from Gemmel, which is German. No, not Gemmel. Gleich Aluminium here in Germany.
Yep.
They saw to size, but they only deal with commercial customers, unfortunately.
Yeah. Anything else down here? Nope, we need to go back up.
I'm not pronouncing that name. Do you think we will ever see small work envelope hobby style surface grinders like we see mini lathes? Garage surface grinding sadly feels quite inaccessible. There is a hobby size surface grinder. The Taiwanese, Chinese, what's it, a 6 by something surface grinder, but it looks a little bit janky, to be honest.
Yeah. I mean, you get into that problem where you need mass. You know, you need the damping mass of a heavy machine to work against the vibrations that even a well-balanced wheel will still have a little bit of, residual vibration. So you end up getting into a corner where there's no stiffness, there's no damping mass, any distortion becomes a larger and larger percentage of the accuracy that you're trying to reach. So for something like a surface grinder, I think you get into a corner where it's not going to really work. The French had that beautiful Lip 515, which Stefan used to have.
That's the smallest practical surface grinder, I would say.
Yeah.
And that's a 200 by 100 millimeter work envelope. My Beamer surface grinder is also a very light duty machine, and it runs exactly the problems that you just mentioned, especially since it's rollerways and not slideways. You have to be careful about wheel balancing, otherwise it will telegraph into the surface finish extremely quickly.
There's a question in there. They notice I've got photos or posters of general aviation aircraft on my wall. Do I only work with general aviation or also some other types? Generally, I mostly work with airliners, but I do some GA work as well. So, yeah. What else we got on there?
Is there a European alternative for McMaster that sells also to B2C, to private individuals? eBay.
Yeah.
It's unfortunately the easiest solution. If you have to find something, just use eBay and somebody will sell the bolt, the handle, the gear that you need. Mädler here in Germany will sell to private individuals, as far as I know.
Yep.
They have some stuff.
They're quite good for sort of all those standard bits like, knob grips and wheels and handles and all that sort of stuff. They've got a very good selection of DIN hardware.
Hoffmann will sell Hoffmann for tooling will sell to private individuals, at least in Germany.
Okay.
And then the air gets thinner and thinner.
Yeah.
Misumi used to sell for private individual, but I think they stopped that. That's the Japanese McMaster.
Yeah. By the way, I got a bit of stress from the way I ended the last live stream, People were like, hey, why did Mark just jump up and run out? Did he go to the bathroom? No, I just don't know how to properly terminate a live stream. So,
it was funny.
Yeah, we'll work through our any more questions here. But if there are no more questions, then I guess we're coming to an end.
There is a question. You mentioned your own projects tooling. Do you have bigger projects like Mark's engine? No, I currently do not get involved with large projects. That backfires on me very quickly, and I know that. And so I don't start to build a steam locomotive right now. That's my retirement project. And I'm also not buying an excavator as a project. Not now.
Yep. Maybe later.
Yes.
There's a question there from Lustig40, who's just bought a Deckel FP3 in CNC, broken, and got it working. If we would compare a Deckel to a Maho, which is better? My guess, you probably get like battles breaking out in Germany over that question.
Oh, absolutely. And you can probably guess my answer.
Probably guess mine too.
Yeah, yours is Maho.
Yeah.
No, you would expect me to say Deckel.
Yeah.
But I think that the Maho machines are on the engineering level better.
Okay.
They have better detailed solutions.
Okay. Yeah, I mean, I have no knowledge of Deckel, so I couldn't. I have no opinion.
I mean, they're all good machines.
Yeah. My methodology of buying machines is, that one looks like it hasn't done much work, and it's got a dead controller. I'll buy it.
Yeah, that's how I would buy a surface grinder if I had to buy a used one. Buy from condition, not from manufacturer.
Yeah.
That's true. For Deckel machines, the part availability is incredibly good.
Yeah.
I can get everything. I just got the replacement gear for the indexing head like in 2 days.
Yeah.
And I didn't have to sell my house for it, like I would have if it was a Schaubelin mill.
Yeah. Okay. Other than that, I guess we're coming to the end of the year, so I really would like to thank Stefan for joining me on these live streams. Wish Stefan a Merry Christmas and a Guten Rutsch, a Happy New Year. And also the same to all of you out there. Thanks a lot for the support of our channels. Stefan put up a 2-hour video just this week, so make sure if you haven't seen it already, go and watch it or watch it again.
Yeah, thank you, Mark. Thanks for having me, and thanks for allowing me to mess around with your stream.
Well, this is great. You see, I'm writing notes the whole time. It's like, this is what I need to do.
This is always great fun, just talking shop. So
yeah.
Wish you the same. Merry Christmas and Guten Rutsch.
Yep. Thanks very much, everybody.
And I hope we can repeat this at some time.
Oh, definitely. Look forward to it. Yep. That'd be great.
Ooh. And thanks for the chat, I guess.
Yep. Thank you.
So, bye.
I need to just quickly switch over because, of course, I need to put on my leaving music.
So we're not live anymore?